Hello and welcome to this short tutorial video on molar mass. This video is aimed at the National 5 chemistry course. So in this video we're going to be using this triangle, which is the relationship between mass, moles and GFM, which mass is equal to moles times GFM, moles is equal to mass divided by GFM. So the first example we're going to do involves the combustion of a hydrocarbon methane. So it reacts with oxygen to produce carbon dioxide and water. And the question is, calculate the mass of CO2 produced when 0.25 moles of methane are fully reacted with oxygen. So if we look at the equation here, this equation is balanced, and 1 mole of methane reacts to produce 1 mole of carbon dioxide. So we can say that 0.25 moles of methane produces 0.25 moles of carbon dioxide. It's a 1-to-1 mole ratio. So using this triangle here, mass is equal to moles times GFM. So we can calculate the mass of CO2, which is equal to moles times GFM, and the GFM of CO2 can be calculated using your data booklet. So oxygen is 16, a gram formula mass of 16, and there's 2 of them, and carbon is 12, so that gives you 44 grams, and that's per mole of CO2. So if we go back to this equation here, we can just simply plug that value in. So there's 0.25 moles of oxygen produced from 0.25 moles of methane, so it's 0.25 times 44, which gives 11 grams. Let's look at another example based on the same equation. So it says calculate the mass needed to produce 0.2 moles of water. So if we've got 0.2 moles of water, it's a 2-to-1 mole, or a 1-to-2 mole ratio, sorry. So we're going to have 0.1 mole of methane needed. So we're wanting to work out the mass of methane needed. So again, the mass of methane is equal to number of moles times the GFM, gram formula mass. And methane, again, you can get this from your data booklet, there's 4 hydrogens, it's 1 times 4, and carbon is 12. So that gives you a gram formula mass of 16 grams. So we put this back into the equation, so 0.1 moles of methane times its gram formula mass, 16, gives you 1.6 grams. Next example, calculate the number of moles of CH4 needed to fully react with 100 grams of oxygen. So we've got a 2-to-1 mole ratio here of oxygen to methane. So we've got 100 grams of oxygen. Okay, so we want to work out the number of moles of oxygen present. So again, if we go back to this, number of moles is mass divided by GFM. So we can work out moles, which is N of oxygen, is equal to 100 divided by 32, because there's two molecules of two atoms of oxygen per molecule, and that gives you 3.125. But because it's 2-to-1, we've got to divide it by 2 to get the number of moles of methane. So moles of methane is equal to 3.125 divided by 2, and that gives you 1.56 moles. So we're not quite finished yet because, oh no, sorry. And the final example, what mass in grams of CH4 is needed to produce 65 grams of water? So we've got 2 to 1 mole ratio of water and methane. So if we work out the number of moles of water first, moles of water is equal to mass divided by GFM, that is equal to 65, and the GFM of water can be worked out from your data booklet. Again, so oxygen is 16, hydrogen is 1, and there's 2 of them, so the gram formula mass is 18 grams. So we say 65 divided by 18, and this gives you 3.61 moles. So it's 2 to 1, so we've got to work out the moles of methane. So the moles of methane is just simply 3.61 divided by 2, and that gives you 1.81 moles. So we're not quite finished yet because it's the mass that we're after. So the mass of methane is equal to N times GFM, which is 1.81 times 16, and that gives you a mass of 28.89 grams. Thank you for listening. I hope you found that tutorial useful. Please visit my website agraytuition.com for more tutorial videos.